Hi. This is a question. A ray of light from a rarer medium. A ray of light from a rarer medium a ray of light from a rarer medium striking a denser medium striking a denser medium striking a denser medium if reflecting light ray is perpendicular to refracting ray, find the refractive index of denser medium. Refractive index of denser medium. That is the question. See here. This is the boundary xy. This separates two different media. One is called air, rarer medium. This is called glass. Say denser medium. This could be a normal. This is a normal. A ray of light now incident on this boundary. It's like this. It's incident like this. So that light is reflected. And a part of light is refracting. This is refracting light ray. Refracting ray. This is reflecting ray. Reflecting ray. The reflecting ray is perpendicular to the refracting ray. So this angle will be equals to 90 degrees. So this could be the angle of incidence. The angle between the incident ray and this one is called angle of incidence, and this is called angle of reflection. Angle of reflection is equals to angle of incidence. This is reflection. But this angle will be angle between refracting ray and the normal is called angle of refraction. This is R. I is called solution. I is PQ is incident ray. This is P. This is Q. QR is refracting ray. And QS is refracting ray. PQ incident ray. QR reflecting ray. QS refracting ray. Angle of incidence equals to angle of incidence I equals to angle of reflection R. I is equals to R. This is according to Snell's law. According to laws of reflection. According to laws of reflection. Laws of reflection. let me write with this. This is according to laws of reflection. According to laws of reflection. So for this boundary, if we apply Snell's law at the boundary, if we apply Snell's law, sin I by sin R, sin I by sin R1 is equal to refractive index of glass, that means denser medium. This is called denser medium. This is refractive index of rarer medium. Refractive index of denser medium by refractive index of rarer medium. See here, the total angle is equals to how much now please? What is this total angle? Angle of reflection plus what? The reflected ray makes an angle 90 degrees with the refracting ray. So this must be equals to 90 degrees plus what? Angle of refraction. That should be equals to what? 180 degrees. Pi radians are 180 degrees. Therefore, this is we can call it as IR. So whatever it is, angle of incidence equals to angle of reflection. I plus 90 plus what? R1 is equals to what? 180 degrees. Alright, what is R1 now? R1 is equals to angle of refraction is equal to 180 minus 90 minus I, angle of incidence. This is 90 minus I. So let us substitute here. Sin I by sin R prime, that is sin 90 minus I. That should be equals to refractive index of denser medium with respect to rarer medium. This is sin I. Sin 90 minus theta is cos theta. Therefore, sin 90 minus I is equals to, that is how much? Cos I. That must be equals to refractive index of denser medium with respect to what? Rarer medium. Sin I by cos I is equals to what? Tan I. This must be tan I is equals to refractive index of denser medium with respect to rarer medium. This is equals to mu. So tan I is equals to the absolute refractive index of the denser medium mu. So this is the result. Mu is equal to tan I. So result for this is, we get mu is equals to what? Tan I. So refractive index is equal to tan value of angle of incidence. This is most important result. Okay, can I explain once again? Right, this is an incident ray and this could be a reflecting ray, because a part of light is reflected and a part of light is refracted in the refracting medium. Reflecting ray, incident ray are in the same medium, air. Refracting ray is in the denser medium. So we can apply laws of reflection as well as laws of refraction. At laws of reflection, we can write angle of incidence is equals to what? Angle of reflection. Angle of incidence is equal to angle of reflection. So angle between incident ray and the normal is called angle of incidence. Angle between reflected ray and normal is called angle of reflection. So incident ray and reflected ray, these two are equal. Right. And according to the Snell's law, for this boundary which separates two different media, one is called rarer medium and the denser medium. As the ray is travelling from rarer to denser medium, it must bend toward the normal. It is bending toward the normal. It would have been travelled like this, but it is bending like this. It would have been travelled like this, but it is bending towards the normal. It is towards the normal. So the angle made by the refracting ray with the normal will be equals to angle of refraction. So sin angle of incidence to the sin angle of refraction is always equals to refractive index of the denser medium with respect to rarer medium. So sin I by sin R1 is equals to refractive index of the denser medium with respect to rarer medium. This is okay. This is according to the Snell's law. We apply the Snell's law. But remember the geometry, what it says, this is normal. N, Q, N prime is a normal. So what is the total angle made by this normal? What is the angle between these two lines? NQ and QN prime. This total angle is 180 degrees. From this can be divided as what? Angle of reflection or angle of incidence. Because angle of reflection is equal to angle of incidence. And this angle is equals to what? 90 degrees. And this angle will be equals to angle of refraction. Angle of incidence, angle of refraction, and this right angle 90 degrees. Angle between the reflected ray and refracted ray is 90 degrees. So R plus 90 degrees, R plus 90 degrees plus R prime is equals to 180 degrees. But angle of reflection is always equals to angle of incidence. Therefore I is I plus 90 degrees plus R1 prime is equals to 180 degrees. We want the value for R prime. So R prime is equal to 180 minus 90 minus I. So R prime is equal to 90 minus I. So let us substitute this value in Snell's law. Sin I by sin R prime. Sin I by sin R1. Sin I by sin R1. R1 is 90 minus I. Sin 90 minus theta is cos theta. Sin I by cos I. That must be equals to refractive index of denser medium in which refracting ray is present with respect to what rarer medium. Mu d by mu r. It's an absolute refractive index of the denser medium. So sin I by cos I is equals to tan I. Tan I is equals to mu. This is the most important formula. This is also called Brewster's law. Thank you.